All right, so let's talk about partitioning. So, so partitioning is a technique that allows us to organize our data, our tables, and our database in general, right, to make it more performance depending on the kinds of use cases that we want to support, especially for databases that might be geographically dispersed, right? That you want to make sure that queries that are for New York or LA or whatnot are performing better, with the putting databases that are nearer to those centers, and it's organized in such a way that might be dependent based on the geography of your data. That might be relevant either by zip code or by international boundaries. Right. So there's different types of partitioning that can be used, either partitioning and creating actually new instances of databases running independently of each other, or within the same database with having multiple tables, or organizing the table in a particular way, again based on various input fields, based on ranges, based on zip codes, based on geographies and how you split it. So let's take a look at a couple ones, right? So first you have range partitioning. Allows you to distribute the data based on some keyword that you want to partition it by. For instance, you might have a zip code, right, where you have independent databases that are running specifically for zip codes that are on the East Coast or the West Coast, where you have all the zip codes data stored in a particular instance that only contain information that is specific to that particular zip code. And so, for instance, the whole database can be divided into partition 1, 2, and 3, where the first one deals with all the zip codes that go from 10,000 to 20,000, and we call that the region 1 partition, right? And it's running way out there in the West Coast. Whereas you might have all the zip codes that go from 20,000 to 30,000, have all the data and records that are relevant to midway somewhere in the middle of the country, and so on and so forth. You might have multiple partitions that you could go even more granular, depending on how populous or how diverse or the density of population for your particular area. You also have list partitioning that you might partition depending on geographical boundaries, where you might have all the countries that are from A to Z in one area. You might have I'm sorry, from that from a particular region of the world. For instance, you could partition and have all South America in one database. You might have all of Mexico through Nicaragua in a different database, and you might have North America in a different one. Canada, USA, Mexico. Is Mexico North America? I'm not quite sure. And so you have you can partition it that way. You can also do what is called horizontal partitioning, where you keep the same database, right? You don't have different nodes and running everywhere. Instead, it's the same database, but you might divide it by the tables, right? So you might have an original table that might have fields that by which you want to partition, right? Where you might have field 2, you have all the values are A, then B, or C, and you might divide it into 3 different tables, right? In 3 different tables that can be indexed independently, can be their performance can be managed independently, but now all the queries, ideally your select statements and your would not be aware that the table had been partitioned, obviously, because then all your query logic would be very complicated. That would need to know that which table do I need to go? Table A, B, or C. Which table do I need to go? Instead, what you do is that we create a view, right, that joins or does a union on all three, so that for the rest of the database application, it looks as if it were one single table, but it's really not, right? It's a union of three different tables that are being independently maintained separately from each other and indexed independently, and the performance for each one is different. The other technique is called vertical partitioning, which is a little bit the same idea here, but instead of splitting it up by rows, right, and say, well, these rows are going to go in one table and these rows are going to be in a different table. Instead, we partition it by columns and say, well, I'm going to have two different tables, but not because they're going to have different rows. They're going to have different columns, because some columns might be faster than other columns, right? There might be some columns that need a lot of updates, whereas some columns are mostly reads, right? And so I might want to direct all the operations that do all the mostly reads to the read mostly table, whereas other data that is dynamic, that is changing over time, and that takes a long time, and you might need to re-index those tables independently into a different table. So, for instance, you might have an original table where you have, say, 4 fields here. You have field 1 and field 2, and these are static fields, right? That they change very little, and most of the operations are read-only operations on these fields. But you have these other fields that are changing all the time, right? That there's a lot of updates, a lot of that are manipulating, and they need constant re-indexing and whatnot, right? Or you might have fields that are very large. They might contain blobs, or they might contain JSON objects in there, and they're very complex data types. And so you might decide to partition and say, oh, well, we'll have 2 different tables, like a fast table and a slow table, right? And then your logic needs to obviously change so that if you're doing all your read operations, they would go on to the fast table, and all your updates would go onto the slow table.